Welcome, infrastructure admins, to this exam prep explainer. Today, we're tackling a topic you are absolutely going to see on the test, NCP-MCI 7.5 1.7 post-installation services. Over the next 10 minutes or so, we're going to methodically break down these exact services. Whether you're aiming to completely ace your Nutanix certification, or you just want to make sure your foundational deployments are rock solid in the real world, this is exactly where you need to be. So grab a notebook, get comfortable, and let's get ready to dive deep into the architecture.
Okay, so here's our roadmap for conquering this objective. We'll start with why post-installation matters, then do a walkthrough of the core cluster setup, followed by another walkthrough on alerts and telemetry. After that, we'll expose some common exam traps, and finally, we'll wrap up with the exact key facts you need to memorize.
Let's kick things off with Section 1, Why Post-Installation Matters, the Bridge to Production. So let's really unpack this idea. Setting up a cluster isn't just about imaging nodes, installing a hypervisor, and hitting the power button. When you finish that initial deployment using the foundation tool, you essentially just have a blank slate. By that, I mean you've got raw nodes with IP addresses and a super basic hypervisor configuration. Post-installation services are that critical bridge. These final, mandatory steps are what actually transform your raw foundation into a resilient, optimized, and fully monitored platform. Think about it. If you skip telemetry setup right now, you're going to be flying completely blind when a disk inevitably degrades a month down the line. Skipping these steps, or doing them out of order, is a guaranteed way to introduce silent instability before you've even migrated your very first production VM. You really have to lay the groundwork properly.
Moving right along to Section 2, Walkthrough, Core Clusters Setup, Storage, Health, and Time.
You know what's kind of awesome about Nutanix? It's how it handles your baseline storage completely automatically right out of the gate. As soon as you create a cluster, the system auto-creates exactly one single storage pool for you. And the why behind that is important. Nutanix strongly recommends keeping your architecture to just this one single pool so you don't create artificial storage silos. A single pool lets the system dynamically optimize capacity and performance across all your nodes automatically. Now, inside that singular pool, 3 default storage containers are automatically spun up. First up is the Nutanix Management Share. This is strictly used for the file storage and self-service portal features, but crucially, and you'll want to remember this, it's also where the system stages binary files during one-click feature upgrades. Second is the self-service container, which is utilized by image service features like OpenShift. And third, you get a default container for your standard guest VM virtual disks. It's an incredibly elegant, ready-to-use setup from minute one.
Okay, once your storage baseline is up and running, you absolutely must verify the cluster's integrity. Enter NCC, which stands for Nutanix Cluster Check. Think of this as a comprehensive, full-body physical for your cluster before you ever even consider going into production. It's a highly robust framework of scripts designed to run hundreds of standard commands against the cluster and the individual nodes. It's checking hardware sensors, software configs, network connectivity, you name it. It's confirming every single service is operating exactly as intended. Honestly, I can't overstate its value. Running NCC has literally saved countless admins from migrating critical workloads onto a cluster that, say, happened to be accidentally connected to a misconfigured top-of-rack network switch. It catches those invisible problems.
Which brings us to a specific command you absolutely have to commit to memory for this exam. NCC Health Checks Run All. You're going to execute this exact string from the command line of any CVM or controller virtual machine in your cluster. When you run this, you're looking for one and only one specific outcome. Every single check across the board must return either a pass or info status. Why? Because those are literally the only acceptable states for a production-ready environment. In an exam scenario, if a question states that an NCC check returns a warning, the correct answer is always to stop and remediate that issue before proceeding. Never ignore a warning, and obviously, never ignore a failure. You have to resolve it, rerun the check, and ensure you get that green light before moving on.
Right, for our next concrete example, let's look at cluster time synchronization. It is incredibly important that your cluster time is perfectly correct. Why? Because in a highly distributed system, time drift is exceptionally dangerous. Core components, like the Cassandra ring that tracks your metadata, rely on extremely strict timestamps just to maintain data consistency. So you configure this by logging into a CVM and using the network command line interface to run ncli cluster set timezone. But here is the absolutely critical part for the exam. After changing the time zone, you have to restart the CVMs to apply the change. Because the Nutanix cluster can only safely tolerate the outage of a single CVM at a time without impacting storage availability, you must restart them in a strict, rolling, one-at-a-time fashion. You stop one CVM,
Wait for it to come back up, ensure it fully rejoins the storage cluster and is perfectly operational, and only then do you safely move on to restart the next one.
All right, let's jump into Section 3, Walkthrough, Alerts and Telemetry, Pulse, Firewalls, and SMTP. So, with the core system stabilized, we need to make sure the cluster can securely communicate with the outside world. It's vital to understand our telemetry rules regarding Nutanix Pulse. Pulse is this great diagnostic feature that proactively alerts Nutanix support to the health of your cluster. Now, a critical fact for the exam is that Pulse absolutely does not gather or communicate any guest VM data, user data, or personally identifiable information, what we call PII. It strictly limits itself to system-level diagnostic and telemetry data. However, for Pulse to successfully phone home and actually do its job, your network firewall has to be configured correctly. You have to allow outbound traffic over port 80 to specific URLs, specifically star.compute.amazon.com and releaseapi.nutanix.com. If you lock down your outbound traffic too tight, Pulse can't communicate, and support won't have a clue if your cluster is suffering a silent hardware failure.
Beyond just phoning home to Nutanix, the cluster obviously needs to be able to alert you, the infrastructure admin, right? For Prism Central to send you any alert emails regarding cluster health or capacity, you are strictly required to configure an SMTP server. That stands for Simple Mail Transfer Protocol. When you set this up in the Alert Email Configuration page, you're defining who gets these critical alerts. Now here's a tiny detail the exam absolutely loves to test. If you're sending these alerts to multiple admins, you must enter their email addresses as a comma-separated list. Watch out for traps that suggest using semicolons or spaces. It has to be a comma. Finally, in these same alert settings, you can enable a remote support tunnel. This feature acts as a highly secure reverse SSH tunnel that lets Nutanix technical support engineers remote directly into your cluster to help with complex, deep-level troubleshooting. It is an absolute lifeline when things go wrong.
That brings us to Section 4, Common Exam Traps, Edge Cases to Watch Out For.
Okay, let's shift gears and look closely at how the NCP-MCI exam might try to trip you up on these standard procedures. You might see a scenario exactly like this on test day. You've got a brand new cluster, you know for a fact you're only deploying basic virtual machines, and you decide you want to clean up unused storage containers just to keep things tidy. The trap here is thinking you can safely delete the Nutanix management share or the self-service container simply because you aren't currently using files or OpenShift. But here is the underlying why. If you delete them, you will completely break future feature upgrades. Like I mentioned earlier, the management share is literally used by the system to stage binary files during one-click upgrades. So the rule to live by is incredibly simple. Never ever delete the auto-created management containers, even if they look completely empty.
Here's another heavily tested concept. The exam will aggressively test your understanding of CVM restarts in the context of administrative tasks, like that time zone change we discussed just a few minutes ago. The trap here is choosing a multiple-choice option that suggests rebooting multiple CVMs simultaneously, usually framed as a nice way to save time or speed up deployment, but you have to remember the foundational distributed nature of the cluster. The Nutanix distributed storage fabric completely relies on these CVMs being active. If you just highlight all your CVMs and hit restart to save yourself 5 minutes, you've just triggered a total storage outage, effectively taking down every single virtual machine running on that cluster. No way. You must always select the answer option that explicitly describes a rolling, one-at-a-time restart. That is how you safely maintain your storage availability. Finally, let's wrap this up with Section 5, the key facts to memorize, your NCP-MCI 1.7 checklist.
All right, let's look at this final checklist. You really want to lock these 3 rules into your memory for test day. First up, licensing. If you are deploying on third-party hardware, which is known as an SWO, or software-only cluster, a specific license is strictly required for insights discoveries to function. This is a bit of a niche edge case that frequently catches admins off guard, so just remember, SWO requires a license for insights. Second, alerts. If Prism Central is failing to send out emails, the absolute first thing you must check is your SMTP server configuration. It's not optional. It's a strict requirement for email alerting. And third, cluster health. Running NCC health_checks run all is your mandatory absolute final gateway. You must see all passes and infos before you even think about moving a single production workload onto that cluster. By understanding not just the how, but the critical underlying why behind these post-installation services, you are perfectly positioning yourself to pass this objective with flying colors.
You now know exactly how to handle the auto-created storage containers, how to manage those strict rolling restarts for time zone changes, how to configure your SMTP and pulse telemetry correctly, and most importantly, how to dodge the most common exam traps designed to trip you up. So I'll leave you with this final, architecture-specific thought to ponder. If a rolling restart safely tolerates a single CVM going offline, what exactly happens if a sudden, catastrophic hardware failure occurs right in the middle of your time zone change? How does the distributed cluster maintain its data integrity in that exact chaotic moment? Keep that in mind as you continue studying, and good luck on your exam.